Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Today we will talk about numbers that has decimal points. Now in programming languages, normally we have two types of decimal point precision. Either it's float or it's double. Float has 7 digits after the dot. Double, as the name suggests, is double the amount, so it can go up to 15 numbers after the dot. So it's 0 point, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. That is the precision that doubles gives you. And the float is half of it. So 1, 2, 3, 4, 5, 6, 7. This is the float. This is the double. So as you can say, double has more precision for math. Now Python is again an exception. It doesn't have any separated definition. It only has one type of float variable, and that float variable has 15 digits as precision. I think so. I'm not sure about that, but I think so. And again, C++, being the godfather of all languages, is a little bit different, because back at old times people were not sure how much precision they would need, and C++ is actually behaving a little bit different. So C++ has float, has double, C# has both of them, and Java has both of them. Same thing goes for all of them. Float is actually 32 bits of data, but the bit usage is different compared to integers. So if you want to see how you should convert the bit value to a float number, you can search the web for that. It's a little bit complex. Double, on the other hand, is 64 bits of data. In all of these languages, even C++. However, C++ has another type, and that is long double. This is dedicated to C++, and others does not have it, because this guy is 128 bits of data, and it has the most accurate precision in all the languages. If you think about it, 16 would give you 7 or 8 digits of precision. 64-bit would give you 15 bits of precision. I assume this guy would give at least 30 numbers on decimal point precision. Do we need it? In normal life? No. In science? Sometimes. For example, astronomical calculations, or I don't know, maybe atomic calculations need this precision. So yeah, if you are doing some crazy math like that, C++ is the way to go. However, when it comes to game programming, forget about this precision. Even double is more than enough for us. Now, I will talk about another concept here, and that is float point precision error. Now, what is this error? As I said, a float, for example, can have 7 digits after this dot here, and a double can have 15. So I will say 7 to 8, because some languages is 7, some languages is 8, but that's the amount of precision you have. Now, if you go in a game engine, for example, this is specially dedicated to mathematic calculations, and you would see it easier in game engines. If you go farther away in coordinates in, I don't know, a 3D world in games, you would get to a point that everything starts shaking. You are not hitting the camera, you are not hitting the keyboard, so your character and camera is not moving, but everything on monitor is shaking, and that is because of this float point precision error. You went so much out there in coordinates that these number of precisions are not enough anymore. You would need bigger amount of precision in decimal points, and normally C# or Java is not producing it for you. So yes, you will have errors there. Everything is shaky, and you can't even look at the monitor. And if you have seizure problems, you may have a seizure attack. So keep in mind, this is a thing that we will have every now and then in 3D games, especially if you want to have open world games that has unlimited amount of train. This was a concept that Lee had talked back old in 3D Boss days when they were doing R&D on open worlds and they wanted unlimited amount of train. So Lee shows in front of the monitor that, hey, if you go, for example, on positive million on X and Z, suddenly everything is shaking up because you have a float point precision error there. Also, the same thing becomes as a warning apparent when you want to compare float points. For example, if you have 0.1230 and another value 0.123, well, in math these two are equal. If in programming we assign A to this value and B to this value, and if we say, hey, is A equal to B, and we ask a question like this, and we use double equations for the programming logic, you will get a warning that, hey, you may lose precision here. And the program is talking about this last zero. It is saying that, hey, this number has more precision compared to this number. If you use equation like this as comparison, we will talk about these type of comparisons later, but if you are doing it like that, then you are ignoring this precision and you may get precision errors. Be careful about what you are doing. Now, it is not an error from compiler, it's a warning. Your program will compile, but it will give you a warning that, hey, are you sure you want to do this? Are you sure that you want to drop this precision here? If yes, then by all means do it. If no, some languages like C# gives you another way of comparing float and double that keeps that precision in mind. So that is something that you should be aware of, the precision error and precision comparison error. So keep that in mind. We will come back to that later when we are writing the code actually in real life and in our real projects. If you like these videos, please hit that like button, subscribe to the channel using the subscribe button, and please inform everyone about this channel, your friends, your family, and turn on that bell so that when I upload a video, you will get informed. Have fun everyone. Bye.